Welcome everybody to another Group 9 demonstration of our car park monitoring system. Today we'll show you the development of phase 2 of our little project. So we've identified issues with finding and managing car parks, particularly in densely populated areas such as CBDs and city centres. So phase 1 of our project looked at developing a sensor that would recognise if a car park was occupied or not, and then it would take a photo and upload it to a bucket. Phase 2 then expands this further and introduces a GUI for the end user so that we can get some interaction, and to do this we employed some relevant cloud components. So again, for phase 1 we were focused on getting motorists off the road sooner and into available parks in order to reduce the congestion. So we were focusing on identifying whether a park was available or not. Now, however, for the focus of phase 2, we are looking at getting motorists to their vehicles, particularly in large or complex parking buildings where it can be difficult to find your vehicle. Now, we've achieved this by utilising AWS recognition, which identifies the location of a parked vehicle based on the number plate. We've also developed a GUI for the end user to directly interact with, so they can enter in their number plate and find it in the database, which will return a picture as well as the location. So if we have an overlook of the current system, you can see up the top here we have our IR sensor, or our IoT device, which is the Raspberry Pi. Once it recognises a change in the status, it determines if the parking is occupied or not. If it is, it takes an image and uploads it to an Amazon S3 bucket. It also uploads an archive image into the archive that we have here. If the car park is not occupied, then an empty string is uploaded to the S3 bucket. Once an action occurs and something is uploaded to the Amazon S3 bucket, this triggers the Lambda functions. Now we have two Lambda functions currently. One recognizes if an image has been uploaded and then initializes Amazon recognition, which then updates the database with the number plate. That extracts the number plate from the image and updates it into the instance with the car parking number, the number plate, and the confidence of the recognition. The second Lambda function recognizes if a null string has been uploaded and then deletes the data accordingly from the database. This then ensures that when an end user accesses the GUI hosted on the Amazon EC2 server and queries for the number plate, the database is responding with the most up-to-date information. So we'll now take you through a demonstration of the application and process. As you can see here, the process of parking a vehicle with the sensors has not changed since phase 1. The vehicle enters the car park and the sensors will realise there is a vehicle there and turn the light red. It'll take a photo and send of the vehicle and send it off to an S3 bucket. The code here relatively stays the same. The key difference is when the save occupied status function is called. If the car park is occupied, an image will be sent to the S3 bucket as well as an archive S3 bucket, and then as soon as the vehicle is removed from the car park, the status is changed to unoccupied and an empty string is uploaded, which then both of these actions trigger a Lambda function, which then one will either initialize recognition and upload the number plate to a database, or if the empty string is there, then the data will be deleted from the database. Once the database has been updated with the number plate, the user can then access the GUI and enter their number plate, which will identify the location as well as a photo of their vehicle. So similarly to phase 1 of our project, the MRT caused some issues as well. What we faced this time was adding an additional command to upload another image, increase the function lifetime. So this caused us some more challenges, and again more research is required in this area. Future works are focused around additional tiers, in particular for event handling, so adding a load balancing, application tier and database just that enable us to be able to handle more queries at a time, which will be good for handling large sporting or social events. So you've seen an overview of the system, you've seen it in action. We've shown you a part of the GUI. If you'd like to view the GUI, we'll add in the IP address to view yourself. The AWS Cloud components that we used were the S3 bucket, the recognition, an EC2 server, and the RDS. And we believe that more development with the system can help it lead to being a commercial product. Thank you very much for your time. If you have any questions, please feel free to post them below or on the forum.